Glad that you all made it so early to the first presentation for today in the QML track. I hope you had a lot of fun yesterday at the party. And I just want to introduce our first speaker. It's Markus Landin from RIM, and he will talk about the new UI framework in BlackBerry 10.
Yeah.
So welcome on stage, Markus.
Okay, thanks. You mentioned the QML track. I actually think this is the BlackBerry 10 track, but it does have a lot of connections with QML as well. So I will definitely touch on that subject. So anyway, this session is called BlackBerry 10 Cascades UI Framework: A Different Take. My name is Markus Landin. I'm a product manager at RIM, more specifically RIM TAT, which is so I'm based in Sweden, in the Malmö office in Sweden. And this is the session abstract. What I will talk about today is I will give you an overview of the Cascades UI framework, show you a little bit about the kind of user interface that we are implementing with Cascades, talk a little bit about the features and also like the underlying architecture and the design principles behind the way we have built Cascades. But before going into the features and the technical details, I feel I would like to show you a little bit about the user interface that we want to realize with Cascades. And when building this new platform, we are also redesigning the whole UX experience, the whole UI experience. And when doing that, our designer has a number of design tenets, and here you can see a few of them, like communication being at its core, moments of charm, and those kind of stuff. But one that stands out is a concept of flow. And in the psychological area, flow was introduced by this guy, a guy called Mihai Csikszentmihalyi. And in the psychological area, this flow is defined as something like a mental state of operation. It's about being fully immersed and energized and enjoy the activity you're doing. So in BlackBerry, the BlackBerry flow is obviously not the same as this psychological flow, but it's definitely related. So in BlackBerry, we define the BlackBerry flow as a seamless user experience. It's about giving the user full control and to keep the momentum going. It's about minimizing context switching and things like that. And one of the important features that we have to implement this flow, to enable this flow, is a feature which we call the peak. And to explain what the peak is, I have a scenario here which illustrates this. So let's say that you are in the browser, you're using the browser in your phone, and then you see this red light flashing, indicating that you have a new email waiting for you, and maybe you're waiting for something important. So by using this swipe gesture, the browser you're using starts to minimize, and then you kind of peek into the BlackBerry hub where you will have all your messages. And if it wasn't that message you were waiting for, you can just reverse this gesture and you go back to where you came from. So the power in this peak gesture is in the reversal of this gesture. So we do the comparison with like how you just look at your watch, like it should be as effortless as looking at your watch. And another example of this peak scenario is when you're in an application. Here we have a list of contacts. You choose to look at, you navigate to a screen with the details of this contact, and then you can use this kind of swipe gesture to navigate to peek back into the previous pages in the previous screens in your navigation stack. And you can either fulfill the gesture and you have that will become a navigation, or you just reverse it and it just was a peek. So that was it about the flow and the peak. So what is Cascades, or rather, what is the Cascades UI framework? Cascades UI framework, that it's the UI framework that you should use when you want to build a native application for the BlackBerry 10 platform. So it does have a lot of similarities with Quick, and it has some dependencies, and it builds upon Qt. so and when it comes to Qt GUI, it doesn't have any like connections to or and so on to Qt GUI. In fact, you cannot use Qt GUI together with Cascades, but it does have dependencies to Qt Core and Qt Declarative. And the Qt version we are using here in the BlackBerry 10 platform is Qt 4.8, currently 4.8.4, and as there are new versions, we upgrade those. But why Cascades? Why not just go ahead with Quick 2 instead? I mean, they seem to be rather similar, right? But the single one most important reason for this is that Qt 5, I mean, it's not ready. It's not going to be ready for BlackBerry 10, and it definitely wasn't ready when we started to build all these different applications that we have for the BlackBerry 10 devices. So we had to create something by ourselves. Another limitation that we think is important with Qt 5 and Quick is that it's QML only. What you can do in QML in Qt 5, you cannot currently do that in the C++ world. Also, there are no native controls anyway. What you have in Quick is rather low level, so we would have had to build like the high level BlackBerry 10 controls anyway. And one great improvement with Qt 5 is the fact that the rendering is done in its own thread, but there are still like synchronization points where the rendering could be blocked by the application, and whereas in Cascade we felt that it was important not to be able to block the rendering. We really want to make sure that we always have that stable frame rate, stable rendering and animations and so on. And yeah, and then we have the fact that when RIM acquired TET 2 years ago, RIM got this quite amazing rendering technology. So we had all of these things already, so we could just go ahead and reuse what we had with like the old generation of Cascades and make kind of the BlackBerry version of it. And so when it comes to some like important facts and design principles that has affected our design choices and so on, is to start with, time has really been of essence. We have built BlackBerry 10 in quite a limited period of time, and having a limited amount of time has really made us to prioritize quite hard when it comes to which requirements and which features to be implemented. And we have taken a kind of a step-by-step approach and extended things as we go, and which we continue to do. So it's been really important to be able to extend things while keeping backwards compatibility. And then another principle is that the uniform look and feel. So it's very important that it should be easy for application developers to create an application, to create applications that are conformant to the BlackBerry 10 UI paradigm. And it shouldn't feel like there are totally completely different UIs in different applications. So, and that the same goes for the controls we are building. So really important to keep them have a uniform look and feel. And then we have this thing about minimizing the development effort. And examples of how we have done that is to the rich set of controls we provide. It's the fact that we use and promote the use of QML. It's the way that we expose animation features and how you work with animations in Cascades. And then when it comes to the controls, we have prioritized building like core controls, stock controls, more than enabling like powerful custom controls. We do have support for custom controls, but it's currently not as powerful as it should be or as it will be in the future. And then finally, we really strive to have a parity between QML and C++. What you do in QML, you should be able to do in C++. And I mean, we have been able to design, I mean, our goal has been to design a UI framework that solves the BlackBerry 10 problems. So that has been our focus. And we haven't really had to pay attention to any legacy or anything. I mean, there are some kind of legacy features in previous version of BlackBerry that we want to have in Cascades as well, like keyboard shortcuts and so on. But this fact has made life quite easy for us. No, really, simplify the requirement picture. And when it comes to cross-platform APIs, I mean, that's kind of a hot topic. It hasn't been our focus. It hasn't had to be our focus. We haven't had time to do that either. There are, of course, similarities with Quick 2 and Cascades. First, the fact that we both have a scene graph. And then the second fact is that we both promote the usage of QML. And then also that we have the rendering in a separate thread. And this is illustrated in this next picture. So this is kind of a high-level picture of Cascades. So what you see here is that on the left-hand side, you have the application in the application thread, which interacts with Cascades APIs that are on the application side, but the Cascades layer is quite thin in the application thread, and we call that the client side of Cascades. Whereas then the bulk of the Cascades implementation is in its own thread on the server side in the render thread. And so these are fully asynchronous. The communication is done through a kind of a inter-process communication messaging, and these two threads can never block each other. So even if the application would sleep, the rendering by Cascades would just continue to flow, which guarantees very stable animations. And the communication back from the server to the client is quite limited. It's not a lot of events that is sent to the client. I mean, the events are actually consumed and used by Cascades on the server side. And if the application wants to listen to events, they are of course sent to the application side. And also there is of course communication where Cascades ask for data to populate the UI, to populate lists and so on. So as you can see, it's and when it comes to the scene graphs, as you saw in this previous picture, there is this UI tree on both sides. But the tree on the application side is not exactly the same as on the server side, because on the server side, what's a button on the client side might actually be a subtree of small and more low-level nodes on the server side. So as you understand, the client side is just a tip of the iceberg. The most implementation is done on the server side. Yes. So, and if we look at the scene graph structure, compared to Quick, we have a slightly more structured approach. So in Quick, you can mix and put different kinds of node more or less as you want to do, where we in Cascades, we gather them into more like categories. So here in this code example, you can see how these more visual elements, the controls, they are gathered in the subtree under the controls category. And then we have another part of the scene graph, which is the animation. So everything that has to do with the animations go into this category. And then we have actions and then attached objects for user object and maybe for visual elements that you want to instantiate later on, that you don't want to be rendered from the very beginning. So if you want something to be rendered, that has to be up together within the controls category and not anywhere else. Event handling. So Cascades application uses slots similar to Qt. So unlike like Qt GUI, where you would subclass and override event handlers. And the server, since the control implementations are on the server side, most of the events are handled there. So when you touch the screen to flick a list, for example, those events never reach the application side, the server side. They're all just consumed on on the server side. And we do have low and high level events, like the low level events like light touch, and high level events like button clicked and so on. And it says here that we have quite sophisticated touch behaviors, and that means that you have a lot of possibilities to configure how touch events reaches and are consumed by nodes in the Cascades tree. And we have different event propagation phases. You can listen to events in the when the event propagates from the root to the leaf nodes, vice versa, or just have the event sent to nodes directly instead. And we have some gesture support. So we have right now we have one gesture, and that is the pinch gesture. And let's see here. Here you see a code example of how you would use a touch event. Up here we have a small square container, a small blue container, which we want to move around. So we specify QML to listen to the onTouch event. So here in this QML code, we say that we change the color of this square from blue to green, and we update the position of this container depending on where the finger is on the screen. Then we have another container down here, which is a square red container. And here we set like the touch configuration that I talked about. Here we set the touch policy saying that nodes underneath this container should not receive any touch events. And if you would only have this code, if you would drag one rectangle to meet the other one, this container we are dragging wouldn't receive these touch events. But for this rectangle that we are moving around, here we can define some kind of touch behavior and saying that we want the events sent to this container using the @target configuration, so it will receive the event directly, so it will never be consumed by the other container. And then we have animations. So similar to Quick, we have a concept called implicit animations. And implicit animations mean that when you change a property, let's say that you have some kind of UI control and you change its XY position, then this property change is animated thanks to this implicit animation. But one difference compared to Quick is that this behavior is not enabled by default. In Cascades, it is enabled by default because we believe that in most cases, you do want to animate things in your UI, and it should be very easy for you to just have the animations without, yeah. Yeah, it is. Yeah, I guess you can say that. So, but you can, but if you don't want to have this kind of behavior, you can configure it away, because I mean there might be use cases where it would just feel strange to have an animation. So again, the animations are run on the server, which guarantees the smooth animations and a stable high frame rate. And when a property is animated, we don't update that property value during the course of the animation, and this is different compared to Quick. And it has a performance problem with it, and also we believe that typically you're not interested in that value anyway. But if you are interested in that value, you can listen to a value changing signal. And here we have an animation example. On the left-hand side, we have a button, and for this button, we define a explicit animation. So here we say that the X position should be changed to 400, and the duration should be 3 seconds. And we're also using an easing curve here. And this animation is triggered when you get the onClicked signal. And here we see an example of how you listen to this property value changing signal, where we write that value to the console. On the right-hand side, we have an example of this implicit animation. So here we also have a button. Down here we have on the on-click signal, we change the X and Y positions with 20 pixels. And if we wouldn't have done anything else, both of these would then have been animated. But now we have code here we have QML here, saying that for the X change, for the change in the X, we want to disable the implicit animation. So the result here is that when you click the button, its X and Y changes, but the Y change is animated and the X change isn't, so it will just jump in the X direction. Cascades has quite a rich set of built-in controls, both kind of low-level and high-level. And when it comes to these low-level controls, it's what you would expect from any kind of UI framework, I guess. We have labels, image views, text fields, text areas, which allow you to input text, drop-downs, as you can see here, toggle buttons, and so on. And what you can see here also in the examples on the right-hand side is we have a control called the page control. So typically, I guess you can say that a page more or less corresponds to a screen. And with the page control, you also get this title bar. And what you also can see here in this example is down here you see some kind of navigation button. So in this particular example, this page control resides in a navigation control. So thanks to this navigation control, you get the navigation for free. It's built into this navigation control. And also the peak behavior that I talked about previously, that's also built into this navigation control. Also we have list control. Here you also see example of, let's see here, this is, what we have done here now is actions. And if you have more actions than you can fit in that bar below, you have a context menu with more actions, which you can open. And then we have another control, which is called the tabbed pane. So instead of navigation, like where you would transition from one page to another, this is more like a tab concept. And also here, if you want to have more tabs than you can fit in the bar, then you can open up and have like even more tabs, like shown in a side menu like this. And what about if you're not happy with the controls that you get with the stock controls that you get with Cascades? So what options do you have to extend with your own functionality? So in Cascades we have this concept of custom controls. There are none of the UI controls in Cascades can be subclassed. You cannot subclass it and override some behavior and so on. We believe in composition over inheritance. This custom control is the only class you can subclass. So what you would do is to subclass the custom control and then use the controls we have in Cascades and add your own behavior, and that would become your own custom control. And also similarly to Quick, you have the possibility to create reusable QML. So you would define your own QML file, put your QML code in there, and then you can reuse that in other parts of the QML. The third way described here on this slide is a concept called the foreign window control. So what this is essentially, you can have a window where you can render anything more or less. You can have OpenGL render into a kind of a screen buffer, or you can have a graphics lib or whatever, do your graph drawing and so on. And then you can use this window as part of your Cascades UI and do translations and animations on this. And this is, one example could be the camera viewfinder rendering in this kind of window control. Simple code example just to show how it would work. So here in the C++ custom control example, you would subclass the custom control, and then you would have code to in C++ build and add the controls you want to have. In this case, a container with a button and then an image view. And then you need to register this this C++ custom control to be able to use it from QML. And in this case, we call it my control. And on the right-hand side up here, we have an example of a QML custom control where you have a file called myQML, myQML in which you put the same UI nodes, a container, then you have a button and an image view. And both can then be used in somewhere else in the QML code. And one advantage of the C++ custom control is that you can hide the implementation from the user and from others and not really allow them to poke around in it. And yes, as I said before, in Cascades, we really feel it's important to have the same things available in C++ as you can do in QML and vice versa. And so the APIs and functionality is almost identical. There are some minor differences in how you do things. For example, for the list view. But they are just minor changes, not really any differences in terms of functionality. And I guess that the reason to use C++ could be, sometimes there can be reasons to go the C++ path for performance reasons, or maybe you prefer the way you debug your code using C++, or maybe you're simply just more used to C++ and prefer that to JavaScript and QML. So it can really be a matter of preference. Something that we have, which is not in Qt, is the builder pattern. And yeah, so here you see a QML example, very simple QML example, and to show how it looks in QML, and then to show how it looks in C++. So on the left-hand side, in this QML example, we have the page control as the root node. And then a page control always needs to have a container where you put the controls you want to have there. And in this case, you have the button. And then here you set the values of the properties of the buttons. And on the right-hand side, you see the C++ version of the same thing, using this builder pattern in C++. So you create the page to which you add and create the container. Then you create and add the button, and then you set the values of the properties. So with this builder pattern, you get kind of a declarative way of creating the UI scene, but in C++. And when it comes to layouts, so the layouts are performed on the server side. Layouts are animated, and unlike, so whereas in QML, you can use anchors to lay out your components. You can anchor objects to their siblings or their parents, while we use more traditional layout API. So we have containers, but we don't have containers which are predefined layouts. They are given a layout. So a container can have a stack layout. It can have an absolute layout. It can have a doc layout. And then controls within these layouts has a layout property. Yeah, we have containers and list views, and currently you cannot implement your own custom layouts. It's something that we definitely going to add in the future, but currently you cannot. And by the way, one really cool thing is I mentioned that the layouts can be animated. I mean, one aspect of this is that if you have a container, and let's say that you have a container which has this absolute layout, and you have different UI controls positioned in this layout. But then if you change this container to have a stack layout instead, the repositioning of the objects in the container is by default animated. So it can give you a pretty cool animated user interface. Here we have a QML example of how you use the layouts in QML. So we have two containers here, one which has a doc layout, the other one has a stack layout. And in the doc layout, we have a button, and in this case, we set the horizontal and vertical alignment, but these are layout properties which are common for all different layouts. So here these properties are directly in the control. Whereas in this example down here, for this button, which is in a stack layout. It uses layout properties which are unique to the stack layout. So it has, so here it has stack layout properties, which we then set, in this case, space quota. Resource handling in Cascades. In Cascades, we make a difference between what we call asset and content. Asset could be icons that you have in a menu like this. So in this case, you want to, I mean, when you show this menu, you really want to make sure that the images, that the icons are actually loaded before you render the page, before you render this menu. Whereas in the content case, this could be images downloaded from the internet. It could be large images, which takes a while to load. So, but in this case, you would want to show this this page, and so the title and the buttons here would be displayed, and then the content would be displayed once it's loaded, and it would be also be displayed with an animation. So in the QML, you can indicate by using a prefix to the URL to the URI whether it should be treated as an asset or as content. Okay, so the data model for list view. I mean, we're not using this Q abstract item model. When we looked at this, we found this to be unnecessarily big. I think it has something like 30 methods and 20 signals. So it was more than we needed. So we created our own Cascades data model, which is much more lightweight, which we use together with the list view. And also another important limitation with the Q abstract item model is that it doesn't support having different kinds of items in the data. So what we want to achieve is to be the ability to have different kinds of items, which then can have different kinds of appearances in a list, for example. And if you do have an implementation based on the Q abstract item model, you can easily wrap this into a Cascades data model. And here I have a code example showing like how the list connects with the data model and how we can have different item types. So here in this case, on the right-hand side, you see an XML file where we have a number of different data items. So we have here we have vegetables and fruits. That's the example here. So we have a header saying fruit, we have a header saying vegetables, and then we have items, one category of the items which are the fruits, it's an orange and a banana, and another kind of items which is that's the vegetables. And then we have the list view in the QML. Its data model points to this XML data model over here. And then we define one list item component, one list item type for the header kind of in the model. We have another kind of list for list item one here for the fruits. And then we have a third appearance, a third type of list item for the vegetables here. And as you can see here in this example, we have, with Cascades, you get a few standard list items, which has its like standard BlackBerry 10 appearance. We have the header item and what we call the standard list item. But you have the opportunity, you have the possibility to define list items yourself, just using the nodes that you have in Cascades. In this very simple example, we are just using a container and a label to define the appearance of this list item. No, I'm told that you should be able to use that, but wrap that in a Cascades data model. I'm not exactly, I don't know exactly how that will be done, but I was told that you should be able to kind of reuse that. But we can look at that afterwards. So okay. Another very important topic is the UI adaptability. The first device that we will release on the market now, based on BlackBerry 10, is a full touch device. That's the one that is coming in the end of January. But there will eventually be a QWERTY device with a square touch screen. We already have the Playbook tablet, which will eventually get BlackBerry 10 running on it. So UI adaptability is about minimizing the effort for you as an application developer to implement applications that support all these different form factors. And I know that the CEO of RIM, Thorsten Heinz, he has talked about licensing the BlackBerry 10 to automotive and other like industries as well. So I mean, there are virtually endless of form factors that we might need to support eventually. So the way we currently kind of attack this problem is that first of all, if you have a simple application and you're using the standard BlackBerry 10 controls, we do have different implementations and different appearances for the different form factors. So let's say a drop-down menu, maybe it has 5 list items on. It shows 5 items on the full touch and 3 items on the QWERTY device. So if you have a simple application, just go ahead and use the stock controls, and your application would work on these different devices. The second approach is to use layouts. I mean, you have the possibility to use the layout controls to make the UI adapt in a smart way to the different form factors. And the third, more powerful feature we have here is what we call static asset selectors. So this allows you to, let's say that you have an application and 90% of the UI should be the same. The implementation should be the same for the different devices. But then you decide that to optimize the user experience, you want unique design, unique implementations for a couple of these screens. So these screens can be uniquely implemented while reusing like the bulk of the implementation. And this slide show how you would structure these assets. And with assets, I mean the QML files and the images. In this example here, you have 2 QML files, two ping files, and this is what would be just used by default. And in this case, the default would be the full touchscreen. But then for the QWERTY device, you decide that you want to have one of these QML files should be implemented uniquely, and one of these images should be unique. It should be replaced. So for this case, you take these assets and put them in the 720 times 720 directory in the assets structure. And this is something that will be handled in runtime automatically. So the system will make sure that the correct assets are used for the right form factor. And in this case, you choose assets based on the resolution, and that is the first selector that we will support. But there will also be like the possibility to have different assets depending on the orientation of the device. Yeah, I guess there are endless possibilities. These are definitely the first ones that we will support. Sure. Yeah, I mean, there will. I mean, I'm not exactly sure what will be in the first version, but sure, you can also use the pixel density and a combination of pixel resolution and density. But I think this is in what we have now in the first version of the static asset selector, and as you say, what you just said might very well come eventually as well as a way to organize your assets. Then when it comes to interoperability with Quick, there is no way to use the visual elements of Quick together with Cascades, but you can use non-visual functionality like the states, like timers. Like having an integration that would render both together would be, they say it would be hard, virtually impossible, so I don't see that happening. And one way to have some kind of interoperability is a concept that we call cards. And cards is a way for one application to expose screens and functionality to other applications. So let's say that I have a Cascades application, you have a Qt-based application where you expose certain functionality on certain screens, then my Cascades application can invoke that functionality as cards, and the experience from the user point of view would be seamless. He would experience it as one and the same application. And this is a concept we use for interoperability with between all different runtimes, Air as well. When you download the BlackBerry 10 native SDK, the Eclipse-based Momentix is what you get as the development environment in this installation. So, and this Momentix is something that has been around for a very long time. It's been the development environment for QNX. It's been the development environment for the Playbook OS. So it's just made sense to continue to build upon this Momentix environment now when we have the Cascades platform. So what we've done is that we have a Cascade-specific plugin which we call Cascades Builder. So it adds support for QML editing. So what we see here is a QML source editor which has kind of standard functionality as you would expect. It has code completion, syntax highlighting, validation, and so on. And one really cool feature is that we have a preview window as well. So as you do your QML coding, you see a preview rendering of this. You see a rendering of this QML in this window. So as you code, you see it in here. We have a component library, a component palette, where you can drag and drop from this palette into the source editor. You cannot drag and drop from the palette into the design view. That is something that will come eventually, but currently you drag and drop into the source editor. And then on the right-hand side here, you see like a tree view of the QML structure that you have, and also a properties view where you can see and edit the properties of the nodes you have in your UI implementation. Yes, and what we have in the future, I mentioned a few features already, like the custom layouts. We're obviously going to continue to work on the controls, add and improve the controls we have, add more core controls, and I really look forward to work more with the fun stuff. I mean, coming from TET and Cascades, our strength was really in like the fun stuff, like transitions, 3D, and so on. Not really the stock controls that we have been focusing on the last year. So I look forward to get that into this framework again in BlackBerry. Visual Editor, what you saw on the previous slide was just the preview of the QML. We are working on the possibility to drag and drop into the design view and visually rearrange and edit the UI. And yeah, moving to Qt 5 will happen eventually, I guess. It's been worked on in prototype, so it's not going to be a technically big effort. Yeah, and if you haven't already, I do encourage you to try out Cascades development yourself. There is, we have this great developer site where you can download the NDK. We have a lot of cool sample apps and pretty good documentation as well. So go there. And there is one more session today related to BlackBerry. It's by Alex Saunders. It's one of the keynotes. That's the last BlackBerry related session. And okay, thanks everyone for coming to this session. I enjoyed being here.
Thank you, Markus.